So here's
half of us.
Half of us are here. Steve is still in Toronto, but he's still involved. You will probably catch him on the next podcast that comes out. Jess, she may or may not be here tonight. We don't know. But if you are around tomorrow, she is actually hosting another conference at Impact. So if you're interested in going to that, then do check out Impact by SciSafe. Well, if you want to keep in touch with us, the best way to get hold of us is using our email, team@dsolg.com. It's very simple. And we'll pick the emails up there. But there are other ways to get in touch with us as well. We've got a website, we have YouTube, we have LinkedIn, we have the meetup, which is how you found us tonight. And we have our podcast, which I just mentioned.
Oh, there we go.
Podcast, DSO Overflow. We have had a bit of a quiet period, but we're back and we have a podcast coming up shortly, imminently, all about AI. And so please do tune into that one when it's available. Do subscribe so you are alerted when it does pop into your platform of choice.
And also on our podcast, if you are interested in, maybe you don't want to get up and speak in person at a meetup, but you would be interested in having a conversation over a podcast, or you have any recommendations of guests that you'd like us to talk to, please do get in touch with us at team@DSOLG, and we can put that forward, because we're always looking for new guests as well to come and join us.
If you are interested in the podcast, just add to that. They only last about 35-40 minutes. The recording time is only about that time. We edit out anything you don't want to, you don't want to share. We edited it out, so don't be afraid. Do come forward, and we'd love to hear your stories about even being in the community. We'd love to hear from you.
And now, as Jess would typically say, we are not a meetup by ourselves. We very much are within a community. I know that we definitely have two people here who have events that are on next week.
Is that Michael?
Yeah, Michael, do you want to shout out about next week?
Michael Mann. So there's another meetup called AI Security Collective about AI security. The event's next Wednesday towards Liverpool Street, Spitalfields Market. We have two talks. One of the talks will be covering agentic security, and the other talk is from representatives from a company called Lakira, so the people behind Gandalf, so prompt engineering, red teaming, type thing. So please attend. Yeah, I'll share the links and stuff with Glenn and co, so that
Just
reach out.
This is the logo, so just look for that logo there on Meetup.
AI Security Collective.
Not missed it.
And Roy, do you want to shout out about BCS next Tuesday?
Yeah. So, hi there. So Roy Harrow. So I'm from the BCS version of this group, and so BCS DevSecOps group. So if you want to look up, we have an event next Tuesday. So just do the search for BCS DevSecOps group. The meeting's in London near Moorgate Station. It's on observability in DevOps, DevSecOps. And we've got a really good speaker, Andrew Hardy, who's spoken before, and he's, as I was saying to Glenn earlier, he doesn't hold back on his opinions, so he's got some really good views, and very entertaining. And so if you would like to come along, it's free, and we have food afterwards at that event. So in case you wonder what's happening, and it's about the same sort of time, about 6 o'clock at the BCS HQ next Tuesday. And you can book on Eventbrite.
Great.
Thank you.
Thanks, Roy.
Thank you, Roy.
And this also wouldn't be able to happen without our sponsors. And so Apiro are one of our gold.
Simon's here.
No, Simon had to go. Yeah, otherwise sorry, I would have thrown to Simon. But instead you have me here. And Apiro is a cloud-based ASPM that helps developers and security teams find and fix vulnerabilities in code before it's released by analyzing the code, the infrastructure and development pipelines, prioritizing risk based on real-world exploitability. But we don't just have Apiro, we have Veracode. Who wants to shout out about Veracode?
Sure.
Veracode are our very kind event hosts.
We've got 5 events here this year, so thank you, Veracode.
Yes.
Really appreciate that.
I'm assuming most people know. In case anybody doesn't know about us, we also have an ASPM. We're just a slightly wider application security platform, specializing in the likes of static analysis. And we also recently, in case anybody hasn't heard, we also recently acquired a company called Pylon, which we are calling basically a firewall for SCA. Anyone's familiar with that? If not, let that be a teaser and you can come and ask questions.
Thank you very much. And thank you for providing food and drink and hosting us, as Glenn says so many times this year. Over to Glenn.
So if you want to become a speaker, we have plenty of opportunities for you. In fact, Prabhsharan is over here. He gave us the talk in February. It was his first talk, and that's what we do. We provide opportunities for you in the community to come along and deliver a talk about a project you're working on, a case study, something interesting, something, whatever. You can last 10 minutes, 40 minutes, an hour, however long you want to last. We can accommodate you. So if you do want to become a speaker here, share your ideas. We'd love to hear from you. So do get in touch with us at team@vsolg.com.
And then finally, save the date. Our next event will be in person at CyberArk, which is near Waterloo. And we have Petra joining us to deliver the main talk. And we will also have a lightning talk too. So yeah, please come along to that. And then we'll be back here at Veracode in May. And the details for that will also be on Meetup soon. So now over to Paul.
Thank you, Paul.
Hey, good evening. Right, so let me just sort this lot out. I'm going to refresh these so that I don't have to log in again later. Just one sec. Oh, you don't want that. That's the end. Oh, you've seen it all now. Oh, have you done the record?
Yes.
Oh, okay, great. Okay, so I'm going to talk about how we save lots of money with a open source project. So the project is around certificate authorities. So is there anybody here that sort of has an interest in using certificates, perhaps for client authentication to something? Getting a few? Yeah. Anybody like to speak about what your specific use case is?
For safeguards and getting microservices to speak with each other safely.
Okay, so that was getting microservices to talk to each other securely. Is that in Kubernetes or in the Kubernetes cluster? Okay, yeah, that's a great application. Go ahead.
We generate a number of certificate signing requests that we'll send off, but we still need some safeties.
Okay, so your interest is more around private key, secure private key storage.
Yeah, we'll get certificate back from. It's signed by their CA, but we still need to protect our keys.
Okay, great. Yeah, you would.
Well, it was actually the same application, sort of service to service.
Okay, so service to service calls.
Authentication and authorization.
Yeah, sounds good. Did you have? There were some hands over here somewhere.
Yeah, the communication service to service. I think it's quite common use case.
Okay, so that's service to service. Is that via APIs?
Yeah.
Okay, like REST APIs or something. Okay, well that's. If I've left anybody out, I apologise. But yeah, that's a good sort of cross section. So that's brilliant. Clearly there are quite a few people here who are very familiar with certificates and certificate authorities. But just in case there's anybody here who might be a bit less familiar, this is just a very quick thing that I'm going to do. So if we just go to a website. Right, so say for example, Google.com. Okay, so that's redirects me to www.google.com, and you can see that there's a padlock. This is Firefox. Google doesn't show padlocks anymore, and it says connection is secure. So I'm going connection is secure, and then I can go to more information, and I could do view certificate. Now the view of certificates is different on every browser. So what I'm looking at here is the certificate for star.google.com. And if I scroll down a bit here, past all these different Google domains, you'll see that there's a public key. So the principle of X509 certificates, X509 being the standard, is that there's a public key and a private key, and that uses a mathematical algorithm that is usually elliptic curve or RSA, such that it is computationally infeasible, I think is the official term. So basically hard and takes a long time, very, very long time, lots of computing power to work out what the private key would be corresponding to that public key. So when I've just connected to Google, the browser did a TLS handshake to make sure that the server that I'm connecting to really has the private key that corresponds to that public key. And then to make sure the certificate's valid, the browser doesn't just do that, but it also looks at what's the chain of certificate authorities that issued that certificate. So we have a intermediate certificate authority just being something that issues certificates. So that signed the certificate for star.google.com. And then ultimately the root, which is signed that intermediate CA, is this Google Trust Services. And that certificate is contained in the Trust Store on the Mac or on the in Firefox Mozilla browser as one of the many trusted CAs. So that's why my browser connected to Google without any complaints. So this is an example of a service certificate, which is one type of certificate. But for but Google isn't doing any authentication of my browser or my device. So for that, I would need a client certificate, and then we'd be looking at mutual TLS, transport-less security, so mutual certificate authentication. So the scenario of that is, if there's a website and you only wanted to let a very small number of people, well, a particular user group, allow a particular user group to connect, then you could issue them all with client certificates. And for that community, you would tend to use a private certificate authority, so not one where the root CA is trusted in all browsers and operating systems. It would be private, so you have full control of who's in that community. So that's sort of the background here. Does that any questions on that? It's probably very familiar to quite a few of you already, but okay. Well, I'm taking silence for yeah, that's perfectly clear. Or yeah, I knew it all anyway. It's boring. But either way, it doesn't matter. We've done it. Right. So now let's just go back to the presentation. Okay. So I work for a couple of companies, and one of the companies that I work for is a company called Q Solution. So Q Solution is a specialist provider of services to the UK government. So we do software as a service and platform as a service services to the UK government. And one of the things that the services tend to be around secure messaging and secure communications between different government organizations and public bodies. And these are a variety of secure messages and secure communications. Now, historically, those communications between different parts of government and the public sector have tended to be all going via private networks. So special sort of private circuits that telecoms provider would put in, and relying on network security to make sure that's all protected and segregated. Now that's tends to be expensive, hard to maintain, and is very old school, really. So there's a increasing desire to move to an internet-based system that is secure enough to be accredited for government use. So when we were developing this, we decided that the good solution for this was to use a private certificate authority, and to issue client certificates to this closed community. So we, because our SaaS services are deployed to the cloud, namely mostly AWS, we use Azure as well for some things. So the first thing we did was look up what AWS services are there that can provide a private certificate authority. So we had a look, and we sort of fell off the chair when we saw that the cost of the AWS Private CA service is $400 per month, and then you also pay 75 cents per certificate as well. Now that might not sound, well, it does sound quite a lot, but it might not sound so much for a company. However, because we set up our environments, which is well, so you should have said, I'm in the way of the screen. Yeah, so because we set up our environments with using infrastructure as code and continuous integration, continuous deployment pipelines, we want to have several different environments, all replicas of each other, all identical effectively. So we need quite a lot of different environments, and we have different sets of user groups as well. So overall, we needed several environments, and for each of those, we wanted to implement a root certificate authority and issuing CA sort of pair in a similar way to the Google example I just showed you. That's quite a common approach. And the $70,000 a year was just too much to contemplate on an ongoing basis. So we had a look at what was available. Didn't really find anything that suited our use case, and decided to develop our own. So the approach that we took was to build the infrastructure in AWS and to use a serverless architecture. So serverless being services like Lambda, which is an event-driven service, DynamoDB, which is a sort of serverless database, and so on. How many of you have sort of deployed, used AWS? So, okay, probably about a third, maybe half. So, and how many of you have used so-called serverless services, or so some? Okay, so the general concept of serverless is very, very attractive, because instead of building a virtual machine in the cloud and installing software and then running that software, all you're doing with a service like Lambda, and I'll show one to you later, you just upload some Python code. Well, it doesn't have to be Python, Java, whatever, but in my case it's Python. So that means that you don't have to worry about the underlying operating system being updated and security patched. You don't spend money on, you do spend some money, but not a lot of money, because you only get charged per use. So if a Lambda function just runs for 10 seconds, you just get charged for 10 seconds. Whereas if you have a virtual machine and it's running all the time, you can end up paying £50 a month or something for that virtual machine. So it's very attractive to create systems and applications using serverless. It's not just lower costs, but it's very low maintenance. So that's why we sort of went for the serverless approach. And the actual certificate authority is built up with Lambda functions. So we've got one for the root certificate authority, one for the issuing CA, and one to issue client certificates. And we store the private keys of the CA in KMS, Key Management Service, in hardware. We use DynamoDB as a database of what certificates have been issued. We use S3, storage service to store various files. Use simple notification service to, where appropriate, send. You can use that to send emails or other notifications that particular types of certificate have been issued. And we publish a certificate revocation list. So this is a list of any certificates that have been revoked because of whatever reason, like key compromise. And we can optionally publish that to a public place that you can refer to it via CloudFront. So that's what we built. You'll see, I'll show it all to you later. So typically, the cost of this is around $5 per month. And that's for an issuing CA, root CA compare. So it works out, there's no charge for certificates. So overall, this is about 0.5% of the cost of if we use the AWS service, which is a very good service. But yeah, but this is about 0.5% of the cost. So that's sort of the background and the architecture. So some of the features, as I mentioned, we store certificate authority private keys in KMS. So when you are looking at a certificate authority or thinking about it, the most important thing to secure is the private keys of the certificate authority themselves, because if that's compromised, then the whole trust of the whole system just breaks down. So we store it in AWS, and we don't just store it there, but we generate it in there as well. It's stored in hardware, and it never leaves there, and it can't, even AWS can't export the private key. So, well, don't think they can. So, anyway, we trust them to quite a large extent as part of the shared responsibility model. So KMS is certified to FIPS 142 level 3. So FIPS is Federal Information Processing Standard. So that's the US standard that's generally regarded as the de facto standard for cryptography hardware. So the certificate authority offers a choice of elliptic curve or RSA algorithms, publishes certificate revocation lists, which optionally you can make public, and if you do, then there's best practice to include a pointer to those that some applications might make use of, called a CRL distribution point, and AIA is authority information access, which is just a pointer to where you can download the certificate authority certificates themselves. That's useful for some applications. Because it's all in AWS, you can be very fine-grained around the access control through identity and access management, least privilege policies. And logging is via a mixture of CloudTrail and CloudWatch for CloudWatch logs. The certificates themselves are issued, they're all issued by automation, so there's no manual issuing of anything. So there are a couple of different ways that you can issue certificates, but it's all in an automated process. So as I mentioned, the whole thing is 100% serverless. It's orchestrated by the different Lambda functions are orchestrated by a step function. So we sort of realized that if we were having this issue about the cost of AWS Private CA, then a lot of other organizations were most likely going to also have the same issue. So we decided to make this an open source project, which we did. And all the details and documentation are on serverlessca.com. So if you're interested in this, that's the only thing you need to remember or write down or whatever, serverlessca.com. So yes, if I just going to go to that site, so serverlessca.com. Yes, this has all the documentation, and it also has links to the actual GitHub repository, which is an open source, the open source repository, which is here. What we've developed is to make it easy, straightforward for people to maintain, to install and maintain, is we implemented this as a Terraform module. So has anybody here used Terraform? So right, quite a few, about half. So which is brilliant. So Terraform is a infrastructure as code language that's declarative. It's very well suited to creating code, infrastructure as code for all sorts of different types of resources, but particularly for cloud. So if you're deploying to AWS or Azure or Google Cloud Platform or many other services, then it's very straightforward to use Terraform. And it's quite easy to learn, at least to get going anyway. And one of the features of Terraform is the use of modules, which are sort of reusable components, a bit like functions in a programming. And modules can be private or they can be public. And this one was made public and published on the Terraform registry. So, so the advantage of doing it this way, or several advantages, so people can just incorporate this into their own way of that they normally deploy infrastructure, into the cloud. And then, literally at the very simplest level, all they have to put in is these 3 lines, and then you'll get a certificate of authority. It's not quite as simple as that, really. I mean, that would get you going, but really you'd want to customize a few things, obviously. But the principle is that it's very straightforward to implement and also to update. So rather than worrying about all the different dependencies, I mean, I still have to worry about that, unfortunately. But I've got some automation to help. But all you need to do is just update the version as and when new versions are available. Run Terraform, and then you're up to date. So so that's the approach that we took. And if you are interested in getting started, there's a Getting Started guide. So Getting Started guide, this is all at serverlessca.com. So this just is a walkthrough to just get a serverless certificate authority into your AWS account, and then to issue some certificates just to get you going. I mean, if you think it's something you want to carry on with, you would then probably have to rebuild it with all your own customization, but it would just get you going, really, and mean you can test it out. So that's the Getting Started guide. So moving back to the presentation, talked about that, and then on the end user certificate. So this is a view in Windows. I quite like the Windows certificate viewer. I think it's a bit better than the Mac one and quite a few others. One of these Microsoft does well, or did well. This was ages ago, I suppose they did that. Anyway, so a couple of different options for issuing certificates. You can directly invoke the relevant Lambda function, or go through a GitOps process where you run the pipeline. You add certificate signing requests files into the pipeline, and then run the pipeline, and then get certificates out the other end. This is a screenshot of an example certificate revocation list. So you can see here there's an example of a certificate that's been revoked. In practice, it's very rare that you have to do that, but it's something that you always need as a tick box for compliance reasons. And you might occasionally actually need to do so as well. So I've spoken about this concept of certificate authority and what it is, but how would you actually use it? So we've had a few different people saying how they might be interested in this sort of use case. So one example is API gateway. So that's sort of your use case, perhaps. So API gateway is an AWS service which you can use to publish an API or application programming interface, as it's like usually a REST API service that other computers can connect to. So this is for machine-to-machine transactions, typically, or machine-to-machine messaging, for example. And then the idea is quite simple, that you require a client certificate on the machine that's calling that REST API, and you only allow authorized endpoints to connect. So, if it's a financial API that does some financial checks, you definitely want to do something like that. So that's API gateway. Then we have ECS. So ECS is AWS service for orchestrating containers. Elastic Container Service. Anybody here use that? Okay, a few. Great. I mean, I really like it. It's nice and simple, so I quite like things that are simple and more and straightforward. So I quite like that. So with ECS, you might use it in the sort of use case that a couple of you were describing, where you want to secure communications between different pods or containers. So there's a principle in the cloud, and I think this was Werner Vogels, the CTO of Amazon Web Services, said, encrypt everything in the cloud all the time, or something like that. Everything everywhere all the time. So yeah, good, very good from a security point of view. You should actually do that. And to do that, you then need, on each of the containers or pods, you need a client server. You need a certificate that has both client certificate and server certificate functionality, so that they can connect to each other in both directions. So that's Elastic Container Service. With AWS, everything's called Elastic. Well, no, not everything anymore. The first products, they all started Elastic. They've stopped doing that now. But here's another Elastic. So EKS is Elastic Kubernetes Service. So you use Kubernetes. Is it in AWS, or do you use another cloud?
Azure.
Oh, Azure. So in Azure, it's AKS, Azure Kubernetes Service, but the same principle applies. So that's EKS. Information of Things, IoT, cool. So the use case here is you might be the Ford Motor Company, and you might want to have all your cars to transmit telemetry data to you and say, this car needs servicing, it's done this many miles or whatever. So I'm just trying to, somebody's got something on that's putting me off, but I'm not sure what it is. Thank you very much. Sorry. Thank you. Yeah, anyway, yes, so you might want all the Ford cars connecting to Ford HQ and upload telemetry data. You don't want anybody else to be able to upload some information that isn't really from a Ford car, would you? So again, you could incorporate, it's quite common to have keys and certificates incorporated to end devices that connect via, via the internet. So IoT Core is one. And yeah, another one is Amazon Workspaces. So this is a sort of virtual desktop type of service which Amazon offer. Became very popular in the pandemic when lots of people needed to work remotely. So it's like a desktop in the cloud, and for some organizations where there's a stringent security requirement, you could say, well, I'm only allowed to connect to Amazon Workspaces virtual desktop if I'm coming from a particular device that has a certificate on it. Application load balancing. So load balancer, ALB. So this is if you want to have a website, a web server, for example, that you only allow a closed group to connect to. And we also have IAM roles anywhere. Was there someone interested in this? Or okay, so IAM roles anywhere is a way that you can connect from a server from completely outside of AWS and get an AWS policy and permissions and authenticate using a certificate key pair. So instead of an access key, secret access key. So that's IAM roles anywhere. So these examples are all AWS. However, this is all standards-based X509, so you could equally well use it for on-premise applications. You could use it for Microsoft Azure, including Azure Kubernetes Service, AKS, or Google Cloud Platform. It doesn't have to be AWS, but it's particularly well suited to AWS simply because the actual code is all, the CA itself is in AWS. But I say the application could be anywhere. So there's some of the use cases. So a month or so ago, I put out a LinkedIn post saying, these are some of the demos I can do. What are you interested in? So got a couple of replies. So thank you very much to those of you who replied. So as a consequence, I'm going to demonstrate the requests that I had, which were the API gateway and IAM roles anywhere. So that's what you'll hopefully see just now. So that's what I'll show you now. So, okay. So let's actually have a look at some of this in action. So first of all, what I'm logged into here is the certificate authority. Sorry, the AWS account that hosts the certificate authority, or CAs, I should say. So if you remember from the design, we use Lambda functions. So these are all the Lambda functions. So as I mentioned, some of you are very familiar with Lambda functions, others this might be completely new. But if I just go to one of these Lambda functions, this is one for issuing a certificate revocation list, you'll see that all it is Python. I mean, this is all it is. It's just 84 lines of Python code. Well, a bit more because there's some modules, but not a lot of Python code. So I make use of the Python cryptography module, which is an excellent, really well maintained module and the best regarded module for Python on cryptography. And then there's some dependencies that have to be sort of included as well. So that's the Lambda function, or one of the Lambda functions. And then this can be triggered in various ways. And yeah, that's the Lambda function. There's not much more to it. There's a few environment variables. Yeah, not a lot to it. It's very, very straightforward. So that's the Lambda function, or an example Lambda function. Let's have a look at the keys. So we go to KMS, Key Management Service. So Key Management Service supports both symmetric keys and asymmetric keys. So for a certificate of authority, these are asymmetric keys, so they're not the same. It's a public-private key pair. So if I go to one of them, like this one, you can see that if we look at the configuration, this is an elliptic curve with a key length algorithm with a key length of 384, and this is the public key. So public keys for elliptic curve algorithms are pretty short, not shorter than the RSA equivalent. And then there's a private key associated with that as well. I have no idea what it is. It's in hardware in AWS, and the pair is generated in KMS. So that's an example of the actual private key of the actual certificate of the CA. Can't actually see the key. Okay, so you saw that there are a few Lambda functions. So we orchestrate that using a step function. So step function is just a way of orchestrating different serverless functions. This runs once a day by default, but I can also just start it manually. Okay, so I've just started the step function. So you get a nice little view here. So it's starting off with the root certificate authority Lambda function. In this case, all it's doing is checking to see if the root CAs already exists. Because it does already exist, it just moves on to the next one. But if it didn't exist, it would create the root CA. Then it issues a certificate revocation list from root CA. Then it checks if the issuing CA is there. If it isn't there, creates it. It's now issuing the certificate revocation list. And now it's checking to see if there's any new certificates that need to be issued. And if there are, to issue them. And these are the certificates for the end entity. So whatever's using the certificates. So that's the process. Okay. One thing perhaps just to mention is those certificates are issued via a GitOps process. But the other way that you can issue certificates is you can directly invoke this the Lambda function that creates the certificates. And the way that I won't be showing this today, but the way that we've implemented this for containers is to have a sidecar container. The sidecar container has permissions to invoke that Lambda function, make the certificate request, gets the certificate back, and then puts it into a shared volume, which can then be accessed by another container on the same pod using the shared volume. So that's the approach that we've used. There are other ways you could do it as well. But so you can invoke when you start up a new container, basically, or new pod. So Okay, so that's what I'll show you. There's, oh yes, and I'll just show you the DynamoDB table. So yes, so I also mentioned that we store details of a record of all the certificates that have been issued are all on a DynamoDB table. Here we are. So we could have a look at some of the different certificates that have been issued. Yeah. So that's enough of the certificate authority. So let's move on now to using some of those certificates to secure an API gateway. So I'll just go back to the presentation, and this is what we have. So here we have an API gateway. We set it up with a Lambda function as a backend to just give a response. And what we're saying here is that we're going to require mutual TLS, so we require a client certificate in order to be allowed to connect, and we're going to trust certificates that are issued by this chain of certificate authorities. So that's what we're going to implement. So see here, there's a link to a Medium article. So everything I'm showing you, you can actually, if you wanted to, you could replicate yourself. And this is the Medium article. And there's also a link to that from serverlessca.com. And also the same content is within that documentation as well. So within here, you've got how-to guides, and under how-to guides, there's a walkthrough of what I'm going to show you, pretty much. So, it's best practice to separate, have the certificate authority account completely separate from the account that's actually doing the application, because they're going to be different sorts of people that look after the different platforms. So it's a good idea to separate those so you get good least privileged access. So I've created another account for the application side of things, which is this one. So let's have a look at API Gateway. So we've got an API Gateway here that I've set up. And if I select this, you can see that we're accepting requests on a particular path /API. I wasn't that imaginative when I did this. And then, giving back a response from this Lambda function. So that's sort of what we're doing here. And then what I did was to set up a custom domain name. So I've set this up with a custom domain name of service.certs.cloud-ca.com, and configure this. You can see that there's a trust store URL. So this is just saying we require mutual TLS. So we will only accept incoming requests if you've got a client certificate, and we'll trust, this is the trust store. So this is the bundle of the issuing CA root CA that we trust. And then if the certificate's been issued by that, we'll give you access. So, so that's so what we've got here. So let's try it out. So if I open this, oops, if I can spell. Can't spell. No, okay. So first of all, I'm just going to do a curl request to that API. So here we go. So that's been reset. So that's not surprising because it requires certificate authentication and I'm not providing any certificate. So now I will reference some certificates that I've previously got from the same certificate authority that I just showed you, and we'll see what happens. So yeah, so we got a successful response. So that's good. And if you wanted it to look a bit prettier, you could use something like Postman, which is an API, a client for making API requests, and we've just got the same message here as well, and it looks a bit nicer. So you can also confirm that we really have authenticated by going into the logs. So in AWS, logs are mostly generally written to CloudWatch logs. So we can go to CloudWatch logs, log groups, and we can look for API gateway access. Sounds hopeful. And we can see that looks pretty current to me. Yes, we can see here, this is details of the certificate, which I just used to connect. So it's all in the logs as well, which is good. So that's the first demo of that's API gateway. So any questions about that one?
AWS provides to manage now content function proxy. Normally, you expect targets to hit these of servers, certificates.
Yeah, so if you used, so the question was about Fargate. So with Lambda functions, you wouldn't normally, they're pretty much, they're not really, generally not used with Fargate, but ECS is, so Elastic Container Service. You've got ECS has a couple of options, and one of those options is with Fargate. And yeah, absolutely, you can. In fact, we do that at Q Solution. We have we use ECS on Fargate. Fargate is like a managed infrastructure as a service that it's sort of invisible. It's all managed by AWS, and you don't have to worry about the virtual machines. But there are virtual machines, but they're just managed for you by AWS. You don't even see them. And that's Fargate. So yes, for ECS, absolutely, you could use Fargate, and then that could be the containers. We could adopt that what I was referring to earlier, which is having sidecar containers that get the certificate when a container starts, and then use that to communicate securely with each other. So yeah, go for it.
Issuing authority for certificates, if we adopt this code.
Yes. So okay. So as an example, so say you wanted to use this for API Gateway, and you wanted to issue certificates to your partners. Yeah, this is a very good question because I glossed over that bit. But yes. So what you could do. So for example, if I go to, so this is where we have this GitOps type process. So also at right, so if I go to github.com/, so the actual organization is serverless-CA. And then within here, we've got a few repositories. We've got the main one, which is this Terraform AWS CA. But then we've also got this is an example of a certificate authority built using that Terraform module. And this is actually the one that I'm demonstrating to you. And what you can do is you could get in this scenario, that you've got a community of maybe third parties, and you want them to get them client certificates. So what you shouldn't do, it's a really, really bad idea, is to create a public-private key pair for them and send it to them by email or something, because then the private key could get leaked. So you wouldn't ever do that. So what you can do is you can, the way that this is structured, you can set up this repository like this yourself, and then you can have a folder where you add the certificate signing request of that third party, and then you can then run the pipeline. So this is all set up with GitHub Actions. So you could run the pipeline, and then that would then start the CA, and then as part of that, that would then issue any certificates that needed to be issued. And then you can collect those via a variety of means. So one means would be collecting it from the DynamoDB database. The other would be to use the simple notification service, and then integrate that with EventBridge, or actually, because when you issue one of these certificates, there's an event that's sent to SNS that contains the certificate. So you can collect that and maybe email it to the person who requested it. So that's the sort of end-to-end process, which means that you never have to log into anything. It's all GitOps. You just get the certificates on request and add it as a pull request, merge the pull requests, run the GitHub actions, and then out the other end you get a certificate. So that's the concept for that use case. It's a bit different for the containers because you wouldn't want to go through that manual process. But does that make sense? Or okay, great, but thank you for asking it. Go for it.
How are you sending the certificate to the requester?
Well, so one way of doing it is, if you remember in that architecture at the beginning, we had a SNS, a simple notification service. So one way of doing it is to extract it from there and then send it via, for example, SES, simple email service. Or you could do it, you could do it in a more manual way, but if you wanted it to be more automated, you could do it in that way. So there's a few options. What we've developed here, what's available as the open source repo, that doesn't include absolutely everything you'd want for a complete end-to-end service, but it does include the core functionality. But some of those sort of housekeeping things and process you'd have to add on yourself, to suit your particular use case. Yeah, go ahead.
Well, I assume you do this as a B2B format in your current work, and I'm wondering what's the sort of life cycle you tend to have with a third-party client like that? How long until they need to reset?
Yeah, so the question there was how long would the certificates last effectively, and when do you have to go through? So it's good practice that any certificate that you issue has a fixed lifetime, because if you had enough computing power, you could eventually work out what the private key is. So it's good practice to make it sort of a maximum of a year. So in practice, if it's that sort of B2B scenario of a user group and a fairly manual process of emails, then yeah, once a year would be sensible. If it's a Kubernetes cluster and you've integrated automated issuing of certificates by directly invoking the Lambda function, then something like 90 days or 30 days would be more appropriate, because that would all be automated anyway. So why not, make it shorter?
Automatic rotation?
So the question there was, does it support automatic rotation? So there's a couple of different models. So for this sort of API gateway model, there's no real way to do that. Well, the API gateway with a community of third-party B2B users, it's really each end user does have to create a new client, a certificate key pair. There's no real way to avoid that unless you start doing something which you shouldn't really do, like creating them centrally and sending them out. So there's not really a way to automate that. But with the containers sort of approach of invoking the Lambda function, then there definitely is, because you could just create, it's good practice to refresh containers all the time anyway. So you can just create a new certificate every time and then make sure that you restart containers every once a week or once a month. So that can be completely automated because it's all under your own control. So where something is all under your control, then you can automate it. But where you're relying on, some person in IT and a business partner, a bit harder to do that, really. I mean, you could by giving them access to invoke the Lambda function, but it would be quite cumbersome. Okay, well, I'm going to move on. So the next use case is the next demo is IAM roles anywhere. So as I mentioned, IAM roles anywhere, it's relatively recent. It's a few years old now. It's a way that you can get a server completely outside of AWS and let them access an AWS environment and give them certain permissions on that environment. And historically, that's always been done with an access key and secret key ID, which is which are quite long-lived credentials, it's generally not regarded as particularly, it's generally regarded as poor practice now. So this is an alternative, uses client certificate, and IAM anywhere can be set up in a similar way to what I just showed you to validate that certificate and make sure it's issued by the appropriate issuing CA and root CA pair. And then if it's authenticated, then it returns temporary credentials via STS, Amazon's security token service, which are then used to access whatever service it might be. In this example, is S3, but it could be anything really. So again, there's another Medium article on this, which you can refer to. So let's have a look at that. So if I go to back to the apps sort of account, and I'm going to go to IAM. So IAM is Identity and Access Management. And then going to go to Roles. And under Roles, we have Roles Anywhere. Sorry, and then I can select Manage. This is a regional service. Here we are. So what we're saying is we trust that this particular certificate authority pair, well, chain, I should say, that's what we're trusting. And then we can create a particular role that makes use of IAM Roles Anywhere. So in this case, we've got one here. And if you look at the trust relationship, we can say, we're depending on roles, IAM Roles Anywhere. And you can also put in conditions. So in this case, I'm saying you're only allowed to connect if you've got a particular organization unit in the certificate. So you can be quite granular about who you're allowed to get a particular role if you wish. So, and then you say what policies you want to associate, what permissions you want to associate with that role. So let's give this one a go. So if I, different color, just to be sort of clear. So I'll just clear that out of the way. So, okay, so this is an example of a connection using IAM Roles Anywhere. So the server that's connecting, or I'm connecting from my laptop, but normally it would be from a server usually. So you do need a signing helper, which is just a bit of software that Amazon provides. And it's actually they're open source. And you specify the various details here. So, and there you go. So I've now connected, well, I say connected, so I've now received a access key ID, secret key ID, and session token. And if you're very, very fast and you type all of this in before it expires in an hour's time, then you can have access to my AWS account. Not very many permissions, but go for it, That's a bit cumbersome doing it that way. So another way is that you can just create a profile in your credentials file, which I've done. I've called it SecOps. So I'm going to just do that. So this is STS security token service, get caller identity. This is just checking what account I'm connected to, which is actually, and what role, which is the right one. So that verifies that. And then if I try and do something with that, so for example, if I just do AWS S3 LS, now this one actually has failed, and that's because I've got this is an optional session profile that restricts access further. It's not really necessary, but I did that just as a demonstration. And there might be certain use cases where that's useful. That session policy restricts access to a particular bucket. So what I can do is download a particular item from a particular bucket. So if I go to here, and then users, right. So you'll see here, got nothing, there's no file here. So now if I do this, that should download a file called confidential.png. There it is. So I've just downloaded that file. It wasn't there before, honest. No, it wasn't. 21 is it? So, well, that's what it was modified. So yes, that just shows you the whole thing in action. And then you can verify. You can look at in IAM Roles Anywhere. So we go back to roles, go back to manage. You can also look at subject activity. So you can see here that just connected here, and this is the details of the fact that I've connected. So again, it's all sort of in the logs that I've connected. So that's iRoles Anywhere. So any questions about that one? No, it's getting a bit late now anyway. So yeah. So let's thank you all for your patience. This has been quite long, but I'm nearly finished now. So a few words on the security if you were to set something like this up. We talked about the importance of protecting private keys, the certificate authority private keys, and a dedicated account. Elliptic curve is the preferred algorithm. It's very important to have processes in place that verify who's requesting a certificate. Otherwise, the whole security just breaks down. And it is important to protect the user or device private keys, ideally with a YubiKey in hardware, ideally YubiKey or trusted platform module. That's not always possible. So at the very least, it's good practice to use the inbuilt operating system certificate store so that there's some protections in there anyway. Carefully control your permissions and monitor logs and update regularly. So that's some security sort of aspects. So these are all the links, but you don't have to write them down. So the links to all of this from serverlessca.com, they're all there. And that's it. So finish now. Go home. Open to any questions. Thanks. Yeah, go for it.
I've got two questions. One, have you looked at any general standards like building security CA, like this standard, and compared it to that?
Well, I've installed the certificate authority module for a couple of different organisations that I work for, both Key Solution, and I'm also working for the National Archives. We've installed it there as well for a similar purpose. And in both cases, we're doing monitoring of the all the AWS accounts with the cloud security platform. And one of the things that does do is compare to the NIST framework and other frameworks as well, actually, like the Centre for Internet Security, AWS Foundation's benchmark. I think on these, these accounts, there's hardly anything there that causes any issues whatsoever, to be honest, compared with a lot of the other accounts in the org. So from that point of view, it's fine. But the other standard, of course, we're endeavouring to follow is X509 for the actual standards of certificates. We rely a lot on the Python cryptography module for that.
So it's like not the NIST CSF, but there's a NIST publication on how to build a CA.
Oh, okay.
Which has a whole load of stuff around user stories and requirements as well. And I think you've picked off a chunk of them already, but I was just wondering if you'd looked at it yet.
No, so this is an open source repo, so we've accepted a lot of contributions from different parties. But also, if you were interested, I'd be very interested to see how you got on and what your assessment was, if that was something you're interested in. My instinct is that a lot of it would depend how you implement it, and the processes you put around it, and the permissions. But I don't know that. But if there were aspects that sort of fell down from the core functionality, I'd be interested to know what they are. Obviously,
second question. Obviously you've got set up for a private CA. Have you considered doing public CAs for like use in browsers and stuff like that?
Well, no, potentially technically it would work, but going through the process of trying to get a root CA into a browser is not something I'm interested in personally. But if anybody wanted to use it for that purpose, I'd be delighted. But yeah, but it's not something I'm going to do. People like Microsoft can do it, and Amazon and Google, but I imagine you have to go through an awful lot of processes to do all of that. But no, thank you. Great questions.
Do we have any more questions?
Yeah, you mentioned service emails the certificate earlier on. You said that you set it up so that an email gets sent when somebody requests a certificate.
So the way that we've set things up with with one of the organizations I'm working with is to do that. So when certificates when a certificate's issued by that GitOps type process of running the pipeline, then the certificate details are all published to SNS. So that's at the moment the scope of the actual module that you get if you just download the module with the Terraform module, is that you get details of the certificate written to SNS. Now, what you can do outside of the actual module is sort of customize that for your own use case. So you can take that SNS message and then process that however you want to process it. But one way that you could process that would be to then take that SNS message, have it trigger a Lambda function that then sends via simple email service, for example. That would be a very viable sort of architecture. But that isn't something that I've written and provided as part of the module. But equally, if somebody wanted to contribute that, I mean, that might be of interest. But I think that might be quite customized for each use case. But all the information is in that stream of events that you could subscribe to, and then that could be emailed. Yeah. Okay, go for it.
Thanks for showcasing the remarkable work which you've done.
No, thanks. Appreciate you saying that.
One question I have is the industry standard is currently they are either adapting to the cloud-based CA certificates or HashiCorp Vault certificates. In what way it's expensive? We could see that. In what way it could be adapted? And second is to the follow-up question, in how well it is adapted in the public sector space, or is it how well it is received in the government area?
So it was well received for our sort of accreditors, so we didn't really have a problem with that. We did have it all independently tested, so there wasn't really a problem with that. So technically, I mean, everything I'm showing here you could do with HashiCorp Vault Certificate Authority. There's nothing wrong with that as an approach. It's just that we didn't want the overhead of another technology. We wanted to use native AWS services. But yeah, it's similar. I mean, you could do a lot of this, probably most of it, with HashiCorp Vault. That wouldn't do I'm not sure that probably does do the CRLs. I'm not sure it publishes them publicly, but yeah, you could use that. That would be fine. Yes. But yeah, as I said, we wanted to use native AWS serverless services. So yeah, go for it.
With your roles anywhere example, the replication lists, does roles anywhere read that list?
So that's a really good question. I'm not sure that it does.
Because once you've issued it to a client and it's using it, how do you stop it from using that?
Yeah.
When it's compromised?
Yeah, so that's a really good question. How do you, if you issue a client certificate to a third party and it's compromised, how do you stop somebody using it? So that was something else. In the interest of time, I didn't cover. So with API Gateway, you can check certificate revocation lists. However, you have to do that with a custom Lambda authorizer. But that does work. I've done that myself. So that's how you do it for API Gateway. I mean, what's interesting is that the way AWS has implemented mutual TLS, they seem to be it's sort of pretty different for every single service. So all these different teams, they haven't done it in a consistent way. With application load balancer, you can upload a certificate revocation list file, and it will check that. So with iron roles anyway, I'm not sure that you can. But so one thing what you could do, but I haven't. So what you could do, just thinking aloud, is you could put. So you know how you have the option of a condition with ARM roles anywhere that I showed you. So you had a condition. So I showed you the example that you could only connect if you had a particular OU. So I'm just wondering whether you could do something like that to say, don't allow access if you have this particular name. I don't know. I'm not sure. I haven't really looked into it.
And make them short-lived.
Yeah, make them short-lived. Exactly. Yes. Yeah, you could potentially do that.
Yeah, I was thinking of the reason for the roles anyway is because it's some automation externally that's,
Mhm.
you know, it would be a manual process to get that key out.
Yes.
You would be looking at a key that's like a year.
Typically, yeah.
But,
Yeah, I'm not. I should have checked that before this meeting, but I wasn't anticipating these nice challenging questions.
Obviously, if you, yes, you could automate it and kind of update your trust policy to sort of say
Maybe.
these are the list of keys that are allowed, but you're limited by default. I think 2K in that trust policy. So we've had lots of times where you can only stuff so much information in there. So yeah, it's a shame to have an ability to check the replication list as well.
Yeah, and it's annoying because a lot of the other AWS services have got a solution for that, but not ARM roles anyway. You should raise it with your AWS account manager if you haven't already as a feature request. Yeah.
Took them years, but I think someone used to request it. You're not the only one who's requested it, sort of stuff. When it comes out, take it.
Yeah, that's right. The more customers that request a particular feature, the higher up the list of things it goes.
I guess the only way to really solve it is to have a role per person or thing that you're doing, and then if it does become compromised, you just remove that role.
Yeah, so what I'd recommend, are you a member of the Cloud Security Forum Slack? So there's a Slack workspace called Cloud Security Forum. Several of us are members. Anybody who wants to join that, just come and see me or one of the people that are members, and we can just get you an invite sent. And that, so it's a community focused on cloud security, really good, some really good people on there. So what I would suggest is you join and ask that question there. The reason I say that is that there's a particular guy there called Liam who works for AWS, and he always responds to any question about ARM roles anywhere. Normally he responds to it. I think he might be the product manager, so that's a good place to ask that question and see what he comes up with. I'll be interested as well, actually, to see what his response is. Okay.
I might have missed it, but what's the extra standby cost?
Pardon? What's the extra?
Standby cost, and then issuing a single certificate. What would it cost?
Oh, so the AWS service is so this is the AWS managed private CA is $400 per month per certificate authority, plus 75 cents per certificate, and then with our one, I mean, I can't guarantee this cost. It's going to depend on how much you use it and so on. But in our case, it's typically about $5 per month. But there's no cost per certificate or anything like that. So yeah, and then that's for a root CA issuing CA pair. Yeah.
Most of that cost is the KMS.
Yeah. KMS, and also if you're publishing publicly, then it's the Route 53 zone. Yeah. Yeah. I think the KMS is like $1 a month per KMS key. And we actually have 3. Again, I glossed over that a bit, but we have another one that we can use for